Hi everyone, you're welcome to this YouTube channel, DML Physics Concept. Kindly subscribe to this YouTube channel. Go to the YouTube and search through the link. You can search through this to allow you. We do that for 435. Search, and when you search, you can click subscribe to this channel. You can like our video, comment, and share this video. Alright, today we want to look at something also very important. Last week we started with the topic when we are looking at the concept of friction. But today we want to continue with the topic titled friction. What is friction? Now, you should understand that walking will not be possible if there are no friction. If there are no friction, it will be very difficult to walk because when the surface is oily, someone will slip and fall because there are no friction. So, how do we define friction? Friction is a force, that's very important, force, and it acts at the surface of separation between two bodies in contact. And something very important is that friction opposes the motion that is producing it. It opposes motion. Now let's consider the image below. If you look at this image, you see that this boy is pulling this body towards the right, and there is a force, frictional force, which is the blue, shown by the blue arrow acting in the opposite direction. And that's how friction tends to behave. It opposes the motion of bodies, as shown here. Now, friction it's very important to understand that there are two types of friction. So we have number one, we call it static or limiting friction. From the word static, it shows that it's a friction experienced by a body at rest. And number two, we have the kinetic or dynamic friction. So as I was saying, the static friction suggests that it's a friction experienced by a body when it's at rest. So every body object has a reluctance to move. So the maximum force you must apply before a body starts to move over another body is called the static friction. So that friction you must apply maximum force to apply before a body starts to move over the body. Then why kinetic motion is the kinetic friction is the friction experienced by a body undergoing what is called uniform speed. So when a body is undergoing uniform speed, it also experiences friction, and that friction is what we call the dynamic friction. In other words, dynamic is the friction experienced by a body in motion, and while static is the friction experienced by a body at rest. Now let's consider the laws of solid friction. So here I will just mention to us 5 laws of solid friction. So, and these laws are very important for every student to know. Number one, that friction opposes the direction of motion. That one is established. That's number one. We have established that. The number two, friction depends on the nature of the surface because uh, if the surface is rough, that is when we have a greater friction. And when the surface is smooth, the friction is reduced or no friction at all. So the rough the surface, the higher the frictional force. So friction depends on the nature of the surface, whether it is rough or it is smooth. Then number three, friction does not depend on the area of the surface in contact. So the wider the surface has nothing to do with friction. Friction only depends on the nature but not the area of the surface in contact. Friction is proportional to the normal reaction. And number five, friction increase to the same extent as the limiting friction. All right, the next thing is that I want to consider some of the advantages and disadvantages of friction. So friction has advantages and disadvantages. So let's look at some of the advantages of friction. Now, number one. So let's look at the advantages. Number one, it makes working possible. If there are no friction, we won't be able to work as I initially explained. Then number two, it makes sharpening of knife possible because there are friction. That's why we can sharpen our knives and some of our objects like that. Then it makes screw and nails to stay tight to the wall. So when we nail a nail to the wall, it stays because of friction. Then automobiles tires makes a firm grip to the road because of friction. Because when we apply a brake, that is when it can stay on the road because there's a frictional force between the automobile tires and the road. The number five, belts that drives machine is possible because of friction. If there are no friction, belts won't be able to drive the machine. The disadvantages, number one, is that machine causes wear and tears. It causes wear and tears as we keep using the object, and because of the friction, it causes wear and tear. Then number two, it reduces the efficiency of the machine. The efficiency of the machine will be reduced because of friction, and because energy will be lost in form of heat. Then it causes heating in the machine. That is disadvantages of friction, and it reduces or opposes motion. Those are the disadvantages of friction. Now let's consider how to reduce friction. So when we are dealing with machines, we must know how to reduce friction in that machine since friction has disadvantages. So Let's look at how to reduce friction. Number one, we use lubricants like the oil or grease. We use ball and roller bearing rollers. Then number three, we polish the surface. When we polish the surface, we reduce friction. And we can also streamline the body shapes, streamlining of the body shapes. And number five, we can also do a kind of separation of surfaces by hair. When you separate the surface by hair, then we reduce friction by that. So now let us consider the frictional equation. So what I mean by frictional equation? When a body is on a smooth horizontal surface or a rough horizontal surface, there are forces acting on that surface. So we look at equations of horizontal surface and also inclined surface. Look, here we want to consider the frictional equation or friction equation on a surface. So this here we have an horizontal surface. If you look at this horizontal surface, let's say we have an object of mass m. The object is pushed forward by an applied force Fa, and the direction of the force is indicated by that blue arrow. So it means when the direction of the force is towards the right as indicated by the blue arrow, we discover that the frictional force is moving in the opposite direction on that surface. Then we have other forces that are acting on that body. You see the downward force. The downward force is due to the weight of the body, which is known as mg. And we have the upward forces. Look at the upward forces, that's the reaction. The upward forces is called the reaction force, and reaction forces is always for every action that is equal and opposite to the action. So when the weight acts downward, the reaction acts opposite. And it's also important to know that reaction always acts perpendicular to the surface. So the reaction to the surface must be 90 degrees to each other. So the reaction acts at 90 degrees to the surface. And then we have the weight of the body acting downward, as I said, due to the gravity. So let's look at another body now. This is inclined surface. If you look at the inclined surface, you discover that there are many components of force around this inclined surface. We have the component of mg sine theta, we have the mg, we have mg cos theta, then we have the frictional force. Then let's look at this next chart. You discover that these are the components of force. But how do we arrive at this component of force? Look at this body. This body is accelerating downward, and we have this component of force around this body. Let's say this body is inclined at angle theta. So how do we arrive at this component of force like mg sine theta, mg cos theta, and mg and the likes of that? So let us go into classroom to analyze the frictional equation on horizontal surface and inclined surface. Thanks for watching. Alright, let us consider a body of mass m. Let's say this body has a mass of m and is placed on a rough horizontal surface. So the surface of the body is rough and the mass is m. So let's say the body is moving in this direction through via a uniform acceleration. Let's say the body is moving uniformly with a uniform acceleration a along this direction. Now we understood that when the body is moving in this direction, and because the surface is rough, there is always a frictional force, and frictional force acts in opposite direction. So let's look at that. The frictional force is going to act like this in opposite direction. Frictional force is going to act in opposite direction. So let's call this one our frictional force. Now, if you look at this object, due to the mass of the object and the gravity acting downward, because the gravity must act on the body downward, then we are going to have a downward force on the body, which is equal to the product of the mass and acceleration. So we are going to have mg here. So there's going to be mg here, which is weight of the body. So this is the force that is going to act downward. Then for every action, there is equal and opposite reaction. So because this object is weight is acting downward, there is a reaction force that always acts at 90 degrees to the surface. So the reaction force is going to act upward. We call this place our reaction force. And this reaction force is also equals to mg. So reaction force also equals to mg because they are opposite reactions. They are equal. So for every action, there is equal and opposite to reaction. So this reaction and this weight will also be equal to mg. So we have this one. Now, how do we now analyze the force of friction around it? If we now look at it, we discover the acceleration here is proportional to the friction. So we can now see that friction, we can say the frictional force is equal to acceleration. You can just say ma, because as the object is moving here, there's going to be a force moving here in this direction. We call it ma. Due to this mass, the force to move this object on this body is equal to ma ma is the force required to move this object in this direction. So we can now say forward reaction and backward reaction, they are also equal, because for every action there is equal and opposite reaction. So in that case, we can also say frictional force equals to ma. So let us recall from the law of solid friction. The law of solid friction also states that frictional reaction is proportional. The frictional force is proportional to the normal reaction. So if I introduce a constant here, we can now say frictional equals to mu r. This sign is called mu. It's called mu. So this symbol is called mu. It's called mu r. So we have mu r. So if I substitute mu r in place of this expression, I'm going to have mu r equals to, because this one equals to this one, mu r equals to m a. So let's make mu the subject of the formula. So if I can make mu the subject of the formula, then the mu is going to be ma over r. So this is how we have the force equation experienced by a body horizontal surface. So when a body is accelerating on an horizontal surface, we have this formula. The coefficient of friction is ma over r. Recall that r is mg. So because r is mg, we can rewrite and say that the coefficient of static friction mu equals to ma, and since r is mg over mg. So we can have this also. And don't forget that we can also divide m to divide m. So the coefficient of static friction, so therefore the coefficient of static friction can be a over g. So we can have that formula. So let's look at inclined surface now. Now let us consider a body inclined at an angle theta, because this is the surface and this is an angle theta, is the angle of inclination. So if we look at this body, let's assume that this body is accelerating upward. So let's say this is the direction of acceleration. So if this body is accelerating upward, then automatically we know that the frictional force is going to act in opposite direction. So let's say we have the frictional force acting in this opposite direction. Then another force that is going to act on this body is the weight of the body that acts downward. So the weight of the body we had vertically downward. So we are going to have mg, given that the mass of the body is m. So we are going to have the weight of the body acting downward as mg. Alright, then we have another force we call the reaction. And remember that reaction force is always perpendicular to the surface. So the reaction force is going to act perpendicularly to the surface. That is, it must make 90 degrees to the surface. So this is called the reaction force R. It's always 90 degrees to the surface. Now, because it's 90 degrees to the surface, then if you look at this reaction, there's going to be a force, because for every action there is equal and opposite reaction. There's going to be a force perpendicular to the surface, and there's going to be another force parallel to the surface. So we have about 3 components of force here. Number 1, we have this force parallel to the surface. We have this force perpendicular to the surface, and then we have the weight of the object that is moving downward. So it is very important that we know what is going to be the component of this force. How do we deduce this one, and how do we deduce this one? Now let's proceed by taking this chart out. But before we take it out, let's first understand that, let's assume that this whole component is a right angle triangle. Now if you assume, let's take it to be a right angle triangle. So if it is not a right angle triangle, then it means if this place is theta and this place is parallel and parallel, so we can say these two, they are corresponding angles. This angle and this angle, they are corresponding to each other. Exactly. Now if this place is theta and this place is 90, then this angle here is going to be 90 minus theta. How do we get 90 minus theta? Because sum of angle in a triangle must equals to 180 degrees. So 90 plus theta plus 90 minus theta, if I sum it up together, is going to give me 180 degrees. So if this one is 90 minus theta, so it means if this angle is corresponding to this angle, look at it, this angle and this angle is corresponding, then it means this angle here is 90 minus theta. So let's take this chart out. Let's take it out. So we are going to have this something like this. We are going to have something like this and something like this. So we are comparing this to this. So in comparing this to this, so this angle here is 90 minus theta. Remember, the whole thing here is 90 degree. If I analyze it, this is a 90 degree chart. So if this angle is 90 minus theta, say it means this angle is going to be theta, because 90 minus theta plus theta is going to give me 90 degree. So which means this angle here is going to be theta. So if it is theta, so this angle is theta. So let's take this side as this one. This one is this one. Look at it very well. This side is this side. So let me draw it very well. So this side is this side. So this is a force that we say it is perpendicular to the surface. Where is this one? This is the force. This force, we can say the force that is parallel to the surface. So this is the force that is perpendicular to the surface, and this is the force that is parallel to the surface. So we want to look at what's going to be the component of this force. So let's use parallelogram law of force. That's when two forces are acting like this to each other, the resultant force can be drawn. Remember, this one is mg. The force that acts downward here is automatically mg. So let's conclude by drawing and make a right angle triangle like this. This is make a rectangle. So this is a rectangle. So let's take this part out. So if I take this part out, we are going to have something like this. I believe you are following. Where this place is the theta, and this is the force perpendicular to the surface. This is the force parallel to the surface. This is our mg. And then automatically we have a right angle triangle. So we can use our trigonometric ratio. We can use our SOHCAHTOA. So using our SOHCAHTOA, we can first find a force perpendicular to the surface. If I want to analyze this now, so first looking for force perpendicular to the surface, we can say this one is going to be the adjacent, and this one is going to be hypotenuse. So in that case, we can say cos theta is adjacent, and adjacent is force perpendicular to the surface, and the hypotenuse is our mg. So if I want to cross multiply now, we can now say force that is perpendicular to the surface is going to be mg cos of theta, and this one is mg cos theta. So let's look at the second component of force. So let's look at the force perpendicular parallel to the surface. So for the force parallel to the surface is going to be opposite to this angle, while this is the hypotenuse. So we can say, in that case, we can say sine of theta is opposite, and opposite to this angle is the force parallel to the surface. That is force parallel to the surface over mg, which is the hypotenuse. So we can now say that the force parallel to the surface is going to be mg sine theta. So force parallel to the surface is going to be mg sine theta. So through this, we are able to resolve all the forces around. So there's a frictional force. There's also another force parallel to the surface, which is mg sine theta. There is a weight acting downward, and there's another force perpendicular to the surface, which is called perpendicular force, and that one is mg cos theta. Then if the body is accelerating upward, then we have all these components. So let's go to find out the equation of friction around this body, but let's put this component into this equation and see what we have now. Hence, we can now put it there that this force is, this place is now mg cos theta, while this place is mg sine theta. Now, when the body is accelerating upward, so then we have two force component of forces acting in the opposite direction when the body is moving upward. So number one, we have the frictional force. Then at the same time, we have the mg sine theta, where this force here is ma, which is F equals to me. So when the force moving upward is me, if the body is accelerating upward, there are two forces acting in opposite direction, which is the mg sine theta, that is force parallel to the surface, and then we have the frictional force. So let's derive an equation around these equations. So since for every action there is equal and opposite to the action, so therefore for this action, acceleration, Fma, that is equal and opposite to the action. So we can say ma here equals to mg sine theta plus the frictional force. And let's recall that the frictional force is mu r. So if frictional force is mu r, let's substitute. Then we can now say ma equals to mg sine theta plus mu r for acceleration. So let's recall that r is mg cos theta, because for every action there is equal and opposite reaction. So r in this context is mg cos theta. So we can now say ma equals to mg sine theta plus mu, and our r is mg cos theta. So let's factorize with m. So our acceleration will now be g sine theta plus the mu g cos theta. So this is how we find the acceleration of a body on an inclined surface when the acceleration of the body is upward. But when the acceleration is downward, the friction will act in opposite direction. We are going to have a similar formula, but in a different direction. So in that case, if the object is accelerating downward and friction acts upward, we are going to have A equals to J sine theta minus mu G cos theta. So that's just the difference. So if it is downward, if acceleration is downward, we are going to have G sine theta minus G cos theta. But if it is going upward as illustrated here, we are going to have G sine theta plus mu G cos theta. Thanks for watching this video. Bye. Kindly subscribe to this YouTube channel. Go to the YouTube and search through the link. You can search through this to allow you Ududari 4435. Search, and when you search, kindly subscribe to this channel. You can like our video, comment, and share this video.